All right, these are fun because they are symmetric, and we can kind of do some tricks here. We can play some tricks when it's symmetrical. So I've got a loudspeaker that's 20 kilograms. Now right away, kilograms is not a force, so I have to convert this to newtons. And that's weight equals mass times gravity, 20 times 9.8. Okay, why am I writing so small? 20 times 9.8, and I get, okay, kilogram bad, newton good, I get 196 newtons. We're dealing with forces, not masses. So the deal is there's two cables that are 30 from the vertical. And there's another one over here. It's also 30 from the... Now, because they're symmetrical, if I had two vertical ropes, and I didn't make my box big enough, they would each take half. And we talked about this in class. So I'm going to take 196 and divide that by 2 and get 98. If there was a vertical rope here, it would be 98 newtons. So just by sheer, if this is a triangle, if that's 30, this has to be 60, right? 60 degrees here. So I have opposite, I have that angle. I'm looking for hypotenuse. That would be sine, wouldn't it? The sine of 60, I will, here, in case you can't see that triangle, we're dealing with this blue triangle. How did I know this was 98 newtons? There's two cables, and if there was two vertical cables, they would each take half. So because it's symmetrical, I can kind of play the game and say, if that vertical cable was there, it would take half. It's not really there, the hypotenuse is, but it works out really nice when you have symmetrical figures like this. So sine of 60 equals opposite, which is 98 newtons, divided by hypotenuse, which is tension in the rope. They're both going to be the same. And then tension by both sides, and then I'm going to have to divide that 60 out of there. 98 newtons divided by the sine of 60, which should make this go up, right? And I get tension equaling 113 newtons. Woo-woo. Now, they're both going to be the same, 113 newtons each. So you don't have to do the problem twice because it's symmetrical. All right. Bye-bye.